Okay, so through the questions, I've been stressing what IRR mean. IRR is the return on a project separate from your own current business. If a project on its own is only bringing back 12%, but currently you um, within your business have the potential to bring back 15%, or you would have to borrow money at 15%. It makes no sense to borrow money at 15% and invest in a project that's only bringing you 12%. That's a no-no. So no, do not take the opportunity. But hey, here's the thing. If you cost of capital or cost of borrowing, if you like, can borrow at 15 and invest in a project that's bringing 17, yes, you will have a positive net present value for sure, right? Yes, and then yeah, if you have a scenario where your IRR is exactly equal to your cost of capital, well, remember that's when NPV is equal to zero, because it means that the cost of capital that you're discounting at, if you like, is exactly equal to the IRR for that NPV to be the internal rate of return in itself is 15% as well. That's why you have an NPV of zero, right? And that's question 100, 103, 103. Let's look at 104. Okay, let's look at 104. So a company is considering investing in a new machine that will cost 3 million to purchase, but this will reduce the operating cost of the business. Okay, great. So the payback is 2.4 years of this machine, and the company policy is to pay back within 3 years. So that's good. That's good. You think, oh yeah, look. So here the payback is with 2.4, which is within the policy of 3 years. And on this you should go ahead, right? On this criterion, it makes sense. It's within your policy. Net present value is 400,000 negative. This is bad, right? So at long term, the net present value is negative, and you should not go ahead based on looking at net present value. The IRR, so the return on the project on its own, is 14%. I repeat, we would have to borrow at 16%. That makes no sense. Borrowing at 16% to invest in a project worth 14%? No chance. So the IRR is below the company's 16% cost of capital, and therefore on this note, you should not go with this. So on the whole, you should not go with this, because the stronger, the more time relevant decision signals are telling you that no, because the NPV, it's a tricky one here. Interestingly enough, I would have gone that the NPV is the dominant criterion. It'd be good to check the answers. I think it's a shame you can only pick one, but please check the answers. I think it's NPV. I mean, NPV, IRR. I think NPV is the dominant one. IRR is almost a re. It just stresses the project a bit more. It just pushes the project. But if the NPV is positive, then go for it. If it's negative, don't go for it. Right? That's the point there. Great stuff, and that's question 104. Stuff. So we have to. There are some questions here. So I think it does. We are asked in our exam to calculate the IRR. Now you can remember the formula, and we will as we keep working on this. But I still think the estimation method is still a good method. So what is the estimation method? And we do see it in the textbook. We know that when your discount rate is 10%, and I'm going to write that here, your net present value is 17,706. And by the time we get to 15%, I'm going to put that as far as possible over here, you are negative 4317. So think of a timeline. It really is a timeline. Think of a timeline. I suppose I could have gone the other way, actually. I should go the other way. Actually, that might be clearer, actually. Well, it doesn't really matter. I could put the 431, if you see what I'm trying to do. I'm trying to put this over here. And does it matter? I don't think it matters. I'm going to do it without thinking about it like that. So here's the point. Here I am at minus 4317. So I'm trying to find the return, what the percentage is when the NPV is zero. I think that's the point. These are all NPVs. So the question here is, because this is minus 4317, right? So I'm coming all the way here from minus 4317 to zero, and then coming all the way up to 17706. You see what I'm doing here? That's what you need to recognize. The question here is, what is this? What is that percentage? This is literally like just gentle ratio comparisons, right? So the first question really I should be asking myself is, well, what is the distance from here to here? Well, the distance on the timeline from 17,706 to minus 4317 is, of course, adding them together, right? So that is 17,706 plus 4317. That is 22,023, right? That's this whole distance. So I'm saying that the 5% distance is the equivalent of 22,023. That's what I'm saying, 5%. So the question then I'm really asking myself is, well, what is, I'm really looking for what is the equivalent in percentage terms of 4317, right? Because 4317 will bring me to zero, Or you could do it the other way. You could say, what is the, you could say, what would 17,706 take us from 10% to it? Let's be creative about this. The point here is that I know I'm going to go with 4317 and work down from 15%, so you can see that. So if I'm looking for 4317, if I know that 5% is this, well, I suppose if I'm looking for what is, I'm really asking, well, then what is 4317 in terms of percentages? Well, it must be, yes, 5% over 22023 times 4317. So 5%, keep it at 5%, just write 5%, 22023 was that times 4317 takes us to 0.98%. So it's saying that, oh, in between here and here, there's a 0.98% drop, right? That's what this is. That's what this is. So if I just subtract 0.98% from 15, right, I will get 14.02, right? I must be at 14.02 along this journey. So really the answer here is 14.02. I think they want you to round up so you can call it 14%. That's kind of the point. That's the best way to estimate this. There is a formula, and you can review the formula. I'm not going to put the formula here because I think it's a bit long. Don't really like formulas. I think if you can understand the estimation, then you're winning. Okay, great stuff. So that's 105. Right, and now let's look at 106. Let's look at question 106. So again, when we talk about IRR, it's really important that we need two NPVs to have a discussion. So what they're doing here is they've given you one NPV. They're saying, listen, go ahead and find another NPV, and then we can do what we just did there with that guesstimation, right? Compare two NPVs and then find something in the middle. So we need to first of all find the NPV at 20%. When we're discounting at 20%, and these are the discount factors for 20%. So let's do that. So we know that the initial cost is, I'm just going to do it here roughly, 75,000 in time 0, right? That's the initial cost. And these are the savings, which is in a way a form of revenue, if you like, because that's what they're really saying here. So I'll just change my pen color. So you have savings of 25,000 annually. So 25,000, and I need to multiply this by 0.8333, and I have 25,000 times 0.694, and I have 25,000. It's a bit of a long-winded one, but hey, it's the very last one. And then you have 25,000 times 0.482, and then you have 25,000 times 0.402. So let's quickly find what that NPV is, because that's what we need to do. So 25,000 times 0.8333 is 20,830. I'll just round it up, 33. It doesn't really matter. Hopefully it won't matter too much rounding up. 25,000 times 0.694, and here you have 17,350. Then you have 25,000 times 0.579, which is 14,475. Then you have 25,000 times 0.482, it's 12,050. Then you have 25,000 times 0.402. Then you have 10,050. So let's add all these together. Let's add all these together, right? And so we have 20,833 plus 20,833 plus 17,350 plus 14,475 plus 12,050 plus 10,050, and that is 74,758. Well, that's what I get. So we have a negative at 20%. We have a negative NPV, right? So, and that's what we want. We want to see, and what is that? That is times 75,000, and that's 242. 242. So now I can get rid of all of this. This is negative 242, by the way. Yes, 242. It's negative, and then I can guesstimate. I can tell you it's probably closer to. You could almost tell you it's probably 18% because it's closer. Sorry, 20%, because 20% takes us into negative territory, and we're starting at positive territory. Again, hopefully you can start to see this. What I'm saying here is at 15%, you had positive net present value 8,800. So you're going all the way down to here at 20%, and you're negative 242. So it means that when net present value is 0, which is what the internal rate of return really is, what is that? That's what we're really looking for, right? So under exam conditions, you probably could push yourself and go for B, but let's test it. So what I'm saying here is that, again, I can look at, you know what I'm going to do this time? I'm going to do it the other way. I'm going to say, well, the distance between 8,800 and this thing and this distance here, 242, must be, right, is 8,800 plus 242. That's the distance. 2490. That's the distance. So I could argue, yes, that the distance, and this is of course relevant, this is parallel to 5%, right? So if I'm looking for this distance, I could say, yes, 8,800 divided by 9042 times 5%, right? Because that's what I'm really ultimately doing. I'm ultimately saying, well, I need to know what percentage of this 5% is there, and then I can add that on. So let's do that. So 8800 divided by 9042 times 5 is 4.86. Okay, right. 4 actually, this is 4.86, so this comes here at 4.86. So actually, if we're rounding it up, I suppose it's actually closer to 20 than what I think about it. 15% plus 4.86 takes us very close. So that's 19.86. And if you're rounding that up to the nearest percentage, it is approximately 20%. I mean, 242 is a small number when I think about it now. So we are actually at 20%. 20% if you're rounding it up. 18 is too small, I know. So 20% is your answer, given our calculations. And I suppose with such a small negative NPV of 242, you can see that that's pretty close. So your answer here is C. Your answer here is C. Well, as usual, we continue to expand on these ideas in class, and the first time you do it, okay, the second time as you do them, it starts to make sense. It starts to make some sense. Oh, great stuff, and that brings us to the end of our videos.